All right, let's dive in and demystify one of the most important things happening in your body right now, blood glucose. We're going to break down what it is, how it works, and why it's the key to your body's energy.
You know the feeling, right? Some days you eat lunch and you feel like you could conquer the world. Other days you eat and an hour later you're looking for the nearest couch for a nap. Well, the secret behind that massive difference? It's all about your blood sugar. So what even is blood glucose? Well, to put it simply, it's sugar in your blood. When you eat carbs, whether it's from bread, fruit, whatever, your body breaks them down into this really simple sugar called glucose. That glucose then gets released into your bloodstream to travel all over your body.
And here's why this is so important. Your brain is a total energy hog. I mean, it's greedy. And while other parts of your body can use other things for fuel, your brain pretty much demands glucose. It needs a steady, constant supply. It's the premium, high-octane fuel for your most critical organ.
Okay, so if glucose is this vital, you'd better believe our bodies have a really smart system to manage it all. Let's take a look at how that incredible internal balancing act actually works.
The best way to think about it is like a thermostat for your energy. It's always running in the background, making these tiny, constant adjustments to keep your blood glucose levels from going too high or too low. It's making sure every part of you has just the right amount of fuel, right when it needs it.
And at the very heart of this whole control system are two key hormones, insulin and glucagon. And there's a really simple way to think about them. Insulin is like the storage key. It unlocks your body's cells so they can take glucose in. And glucagon, that's the release key. It unlocks the glucose you've already stored when your levels start to dip.
You can see how they have this perfect push and pull relationship. So you eat a meal, your blood sugar goes up, and insulin jumps into action, telling your cells, hey, open up, time to take in some fuel. But then, if you haven't eaten in a while, glucagon taps the liver on the shoulder and says, okay, time to release some of that stored up energy. It's a beautiful system.
So, with that whole hormonal system in mind, let's talk about what actually happens right after you eat, because this is where things get really interesting for most of us.
Okay, so after any meal with carbs, your blood glucose is going to go up. That's totally normal. It usually peaks about an hour after you eat. And then, as insulin does its job, your levels slowly come back down to your baseline over the next couple of hours. This whole up and down curve is what scientists call the postprandial response.
Now, when that rise and fall is super sharp and super fast, well, it gets a much more memorable name, the glucose roller coaster. You know this feeling. It's that quick hit of energy followed by that sudden, steep crash that leaves you feeling drained.
And while glucose roller coaster is a great way to picture it, the actual scientific term for these swings is glycemic variability. And this is a really key metric because it tells a much bigger story about what's going on with our metabolic health.
Which, of course, brings us to the most important question of all. A little up and down is normal, we get that. But why should we really care about these big, frequent swings in our blood sugar? What does it actually do to us in the long run? Well, constantly riding that roller coaster puts a ton of stress on your body. It makes your pancreas work overtime, pumping out insulin. Over time, all that high variability is linked to things like inflammation and oxidative stress, which is kind of like cellular wear and tear. Long term, this can increase the risk for metabolic problems. And it's not just long-term stuff. It affects you day to day. That afternoon brain fog after a big sugary lunch, that's glycemic variability in action.
So, if the goal is to get off that roller coaster and have a gentler ride, how can we possibly predict how a food is going to affect us? Well, one of the most famous tools ever designed for exactly this is the glycemic index.
The glycemic index, or GI for short, is basically just a ranking system. Scientists take a food, give it to people in a lab, and then they measure exactly how quickly and how high their blood sugar goes up. Then they score it on a scale from 0 to 100, where pure glucose is a perfect, fast-acting 100.
And based on those scores, foods get sorted into three main buckets. You've got your low GI foods, like lentils and most veggies, that digest slowly and cause just a gentle rise. Then you've got high GI foods, like white bread and soda, that digest super fast and cause that big, rapid spike. The idea seems simple enough, right? Just stick to the low GI foods to keep your blood sugar more stable.
But is it really that simple? Can you just look up a number on a chart and call it a day? Well, as you've probably guessed, real life is always a little bit more complicated than that. Look, the GI is a really helpful guide. It's a great starting point. But its biggest weakness is that it's based on tests done in a lab with single foods. And that's just not how we eat in the real world.
Here are the big limitations. First, we must never eat just one food by itself. We eat meals. And as soon as you add fat or protein or fiber to that meal, it completely changes how your body responds to the carbs. The GI also doesn't really consider portion size. And here's the biggest one of all. The glycemic index is an average. It's based on a group of people. But the science is crystal clear that my response to a banana can be wildly different from your response.
So what this all boils down to is this. Instead of getting obsessed with a single number for a single food, the real goal is to think about the overall shape of your glucose curve after a meal. We want to promote those gentler, more stable responses by understanding how combinations of foods, and not just carbs, affect your unique body.
And that really leaves us with the most fascinating question, doesn't it? We know the science is based on averages, but we know our own biology is deeply personal. So the real frontier here isn't some universal chart. It's the data of one single person, you. What does your personal glucose curve actually look like?